Hi everyone, we are going to the problem solving for the topic on temperature. Now, as already covered earlier, the idea behind solving such questions is that the property of a body varies linearly with temperature, and this will serve as a measure of temperature itself. Now, what we are given here is a question on resistance of a platinum resistance thermometer, which is 6 ohms at 0 degrees Celsius and then 8.4 ohms at 100 degrees Celsius. Now what you want to know is to find the temperature when the resistance is 14.4 ohms. So in this case, the physical property of the material is actually the resistance. So specific to this problem, it is the resistance that varies linearly with temperature. So the resistance will serve as a measure of temperature. Now first things first, you know it's a linear relationship and it's a straight line graph. So what we're going to do, sketch the resistance versus temperature axis first, and then sketch the first coordinate, which is 0 degrees 6 ohms, and then the next coordinates, which is 100 degrees Celsius 8.4 ohms. Now since it's a linear relationship, we just draw a long straight line cutting through these two coordinates. And now we want to know at 14.4 ohms what's the temperature. Now if you look carefully, 14.4 ohms is actually greater than 8.4 ohms. So therefore, the temperature theta has to be larger than 100 degrees Celsius. We do not know how large, it just has to be larger. And hence, we locate the unknown temperature in this way. So as per normal, we're going to label these three coordinates A, B, and C. And we're going to go back to the very basics. Gradient AC equals gradient AB. So for gradient AC, R theta minus R naught over theta minus 0 equals R100 minus R naught over 100 minus 0. So specific to this, R100 refers to the resistance when the temperature is at 100 degrees Celsius, and R0 refers to the resistance when the temperature is at 0 degrees Celsius, and R theta is the resistance when the temperature is at theta, which is the unknown temperature. So what you're going to do is to just plug in the values from the graph, and then through mathematical manipulation, find the unknown temperature theta, which is at 350 degrees Celsius. So again, to summarize, go back to the very basics. The resistance varies linearly with temperature, so we know it's a straight line graph. Get the axis out, the graph, gradient.